Number one, part A, is one where I have to evaluate this limit as it goes to 0. Just to quickly point out, when I plug in 0 for my delta x, I get a fraction with a 0 in the bottom, and I can't have that, so I have to use our different... I can't just plug in my 0 to all these x's. It would be nice if we could, and for some we can, but so I need to use limit techniques to solve this thing. So what I'm going to do is kind of work exclusively with the top for a little while, and it'll eventually take care of the bottom. So I will, and what I'm going to do is find a common denominator for these two fractions. So to do that, I'm going to multiply this by this, and I'll show you what I mean by that. So I've got 5 over 4 plus, actually, so what I'm going to do is change the delta x. Kind of looks confusing, and it's just more to write, so I'm just going to change it to x. I could change it to h or whatever, but oftentimes when we're working with limits, we write x. So, alright, so it's the limit as x approaches 0 of, back to red. So what I was saying is I need to find a common denominator. So what I'm going to do is multiply this piece by 4 over 4. That comes from this 4. And then I get minus 5 over, in my common denominator piece here, I need to use that. So I need to multiply by that over that. Just like I multiplied by 4 over 4, I'm going to multiply by this over that right here. So I get 5 over 4, 4 times, open parentheses, 4 plus x over 4 plus x, like that. And that is all over, don't forget about this piece, my 3, I've changed it to an x. Alright, so I'm going to do some work to kind of combine terms here. First off, everything's going to be, so I'm going to write my limit as x approaches 0. I've got to always include that piece. I've got 5 times 4. Then I've got 5 times 4 plus 5 times x. So I'll write that out. Minus 5 times 4 minus 5 times x. That is all over my common denominator, which is this and this, or I should say this or this. One thing, notice I distributed my negative into the 5 times x right there to give me a negative there. It's not a positive. It's not just 5 times positive x. Got to include that guy. So my common denominator is, I'm going to write it as 4 times 4 plus x, because I like to have that piece out front. And this is all over 3x. Now, it sort of looks a little messy, but look, I got 5 times 4 minus 5 times 4. I don't even have to multiply it out. I know that they cancel. And I'm also going to, so it's limit as x approaches 0 equals. I've got a negative 5x in the top, and it's over 4 times 4 plus x. And now what I'm going to do, I'm going to do a couple steps at once here. I've got this fraction, and I'm trying to divide it by something. So if I had, let's say, 3 over 7 divided by 20, well, I could say 3 over 7 times 1 over 20. This 20 corresponds with this piece. So this fraction is in the same form as this thing. And I'm going to rewrite it like this. So instead of writing another fraction bar down here and writing my 3x there, I'm going to write it like this. So you should see things starting to cancel here. Let me give myself some more space. You should see things starting to cancel here. I get a x that cancels there. And that's about all. So I'm going to rewrite this. You don't necessarily have to rewrite it at this point, but I am going to do that to make it easier to see. Limit as x approaches 0, negative 5 over, I've got 3 times 4 times 4 plus x. I just moved the 3 over to here. So, now I just gotta plug in 0. There's no problem. Remember I said up at the beginning I couldn't plug in 0. It gave me fits or whatever. So you can see now that I can plug in 0. So that is equal to negative 5. Notice I'm like waiting till the end to deal with all my multiplication stuff. And I'll do a little bit right now. So I have a over 12. That's 3 times 4 times 4, which gives me negative 5 over 48. And that's my answer. Now, you may be like, oh my gosh, that was so long, but that's probably one of the more lengthy types of limit problems that you'll have to see. So hopefully you're okay with that.